In this video, we're going to talk about some of the different bisectors that we run into when we're working with triangles. The first bisector we're talking about is the perpendicular bisector. Obviously, if you remember, the word perpendicular means that it crosses, it's two lines that cross at a right angle. So a perpendicular bisector, a bisector is something that cuts something in half. So a perpendicular bisector is a line that crosses the side of a triangle at a right angle, and it cuts that side in half. So in this case, line CD is the perpendicular bisector of side AB. All right, and um, these different bisectors are going to have different properties that go with it. You notice that line CD crosses at a right angle. You can see that by that little right angle symbol square right there. So the property that we have with a perpendicular bisector is that any point that is on this perpendicular bisector is the equidistant from the two vertices. In other words, any point on line CD is the same distance from A as it is from B. All right, so um, the converse of that, or the opposite of that, also says that if there's any point on on a line that's equidistant from any two vertices, then that line that it lies on has to be a perpendicular bisector. All right, and when we're talking about, obviously we're in a triangle, we have three different sides, so we're going to have three different perpendicular bisectors. All right, and where those three perpendicular bisectors meet, you can see here you have a perpendicular bisector right here, one right here, and one down here. And whenever you extend those, and once they cross right here, that point is called the circumcenter. And that circumcenter is an equidistance from from all of the vertices of the triangle, because that is the one point that they have in common with all three of the perpendicular bisectors. So pause this video and copy these notes into your notebook. All right, the next bisector that we're going to talk about is the angle bisector. And when we're talking about an angle bisector, once again, remember, a bisector cuts something in half, okay? Well, obviously, if it's an angle bisector, it's going to cut the angle in half. So, so in other words, BF, ray BF, is the angle bisector of angle DBE. And what that does is that angle DBF is going to be the same measure as FBE. All right, so a bisector cuts them in half. So both sides of the angle on both sides of the angle bisector are going to be equal to each other. All right. Also, along with that, the big property that goes along with the angle bisector is that any point on this angle bisector is going to be equidistant, or the same distance from the sides of the different angle. And you notice here that it's the sides are measured at a right angle. From a right angle of the side up to the angle bisector is going to be the same to for both sides. Okay, and also the converse says that if you have a point that's on the interior of an angle and it's the same distance from both sides, then that means that that is that point is on the angle bisector, okay, or on the bisector of the angle. All right. So once again, because we have three angles, we're going to have three angle bisectors, and um, the three angle bisectors here from A down to here. Oops. From That's an angle bisector. Okay. This is an angle bisector, and this great big long one is also an angle bisector. Okay. Those meet, where those meet, that's called the incenter. All right. And the incenter theorem says that this particular point, the incenter, is the same distance or the equal distance from the sides of a triangle. And one real life application that you can run into with this is that if you are trying to balance a triangular shaped object, this incenter is the balance point of of a of that triangular shaped object. Okay, so pause the video and copy this into your notes, and then we'll do several examples. All right, so this first example, it says find the value of x, then find the length of fg. Okay, so if we look here, if we look at what we're given a line that crosses side FG at a right angle. So that is a perpendicular bisector. And according to the perpendicular bisector theorem, that means it's the equidistance from the two endpoints, or from the two vertices of the line that it crosses. So from F to G is the same distance as from D to G. Well, so to solve for x, we're just going to set those two equal to each other, those two equations equal to each other, expressions equal to each other. So we have 5x minus 17 is equal to 3x plus 1. All right? And we're going to solve for x. So minus 3x on both sides. This cancels out. We're left with 2x minus 17 is equal to 1. All right? And then we add 17 to both sides. And when we do that, 17's cancel out. We're left with 2x is equal to 18 divided by 2. And x is equal to 9. All right? So now that we know that the value of x is 9, we just plug it in. Okay? FG. So we're going to say 5 times 9 minus 17 gives us 45 minus 17. All right? If we get our calculators and go 45 minus 17, we end up with, a value of 28. So the length of this side is 28. Obviously, the length of the other side is also going to be 28. And if you plug it in, 3 times 9 is 27, plus 1 is 28. All right? So that's because, and we can figure that out because this is a perpendicular bisector. Okay? All right. Next one. Once again, we can see that it crosses at a right angle. Okay, so that means that it's a perpendicular bisector. Okay. And means we're going to set the two sides TU and UR equal to each other. So we have 2x plus 24 is equal to 5x minus 30. Okay? Solve for x. So subtract 2x. We end up with 24 is equal to 3x minus 30. Add 30. Okay. We end up with 54 is equal to 3x divided by 3. And 54 divided by 3 is 18. So 18 is equal to x. We're supposed to want to find tu. That's this one up here. So that's 2 times 18. We should say 18 is equal to x. 2 times 18 plus 24. Okay, that's this right here. Just plugged it in. Okay, 2 times 18 is 36 plus 24. 36 plus 24 is 60. So the length of side TU is 60, which means that also that length of side UR is 60. All right? The next problem, it says find the measure of angle FYL. Well, now here's the thing, FYL, that's this angle right here. Well, so the thing is that we see here that this point L here is equidistant from the two sides of the angle. So that means this is an angle bisector. All right. So that tells us that if that's 58, then that over here has to be 58 degrees as well. All right. So that's pretty straightforward there. Okay. If we wanted to find the measure of the big angle JYF, you would just add 58 and 58 and end up with 116. All right, find the value of x, then find the distance of IU. Okay, you notice here that the two angles are the same. Okay, so that means that this line here RU is an angle bisector. That means that TU and IU are the same distance away from the sides of the angle. We're going to set them equal to each other. Okay, so 2x plus 5 is equal to 7x. Subtract 2x minus 2x. We end up with 5 is equal to 5x divided by 5, and 1 is equal to x. So the value of x is 1. And then to figure IU, that's this right here, so that would just be 7 times 1, which is equal to 7. So the distance U is 7 units away from the side RI, if we're looking at a right angle. And even though these don't have the right angle symbols, these are right angles. Okay. All right. Once again, here we're going back using the converse of the angle bisector. Okay. So this past one, this one up here was angle bisector. Okay. So this next one is the converse of the angle bisector, because converse of the angle bisector says that if we have a point that's equidistant from the sides, then it lies on the angle bisector. So it says M is the same distance from side YP as it is from YW. You can see that by the congruency symbols here. So that means this is an angle bisector, means these two are congruent to each other. Okay, so we have 4x minus 1 is equal to 2x plus 5. Okay, subtract 2x from both sides. All right, we're left with 2x minus 1 is equal to 5. Add 1. Ones cancel out. 2x is equal to 6 divided by 2. X is equal to 3. So the value of x is 3. Okay, so then it says find the measure MYW. MYW is this one, this angle right here. So we go 2x plus 5. It turns into 2 times 3 plus 5, which is 6 plus 5, which is equal to 11. All right? All right, so the next one deals with a circumcenter, okay? And it says that we're given that point P is a circumcenter of triangle ABC. Remember, the circumcenter is associated with the perpendicular bisectors, okay? So that means that this line here, and this line here, and this line here are all equidistant from the vertices, okay? So which segment, it says which segment is congruent to segment BR? Well, BR is this right here, right? Okay, that deals with this perpendicular bisector, so that means this right here, AR, is congruent to segment BR, okay? All right, then it says which segment is congruent to segment CS? Well, CS is right here, okay? This is the perpendicular bisector for that, so that the side is AS, okay? That's side AS, all right? And which segment is congruent to segment BP, okay? Well, let me erase some of this, okay? So P is the in-center. P is the in-center right here, okay? So which segment is congruent to BP? Well, then that is that um, all any of these, any of either AP, okay, AP or CP are both congruent because this is equidistant from the vertices of all three vertices of the um, of the triangle. Okay. Our last example that we're doing, it says point A is the in-center. Okay. In-center. Remember, in-center deals with the angle bisector. Okay. It's where the angle bisectors cross. All right. So when we know that, it says what is the measure of angle ARU? So ARU, that's this angle right here. Well, so when we do that, we know that this is 40. So the measure of ARU is going to be 40 degrees. Okay, that's that right there because AR is an angle bisector. Okay, because AK and AU are equidistant from um, from from the um, from the sides of angle ARK. Okay, what's the length of segment AU? What's the length of segment AU? Well, okay, so that because we're talking about we're talking about. Let me get a pen. AU is this right here. Okay, so the only other length that we're given is the length of this side right here, AT. Okay, AT. Well, so that's here, all right? But so AU is dealing with the incenter, and the incenter is the same distance from all three sides. So we know the length of side AU is 20, okay? And then it says, what's the measure of angle QPA? QPA, okay? So that's this angle right here, all right? That's this angle right here, all right? And we know this is the angle bisector, so we're going to set these two equal to each other, solve for x, and plug it back in. 3x plus 2 is equal to 4x minus 9. Okay, subtract 3x. All right, we're left with 2 is equal to 1x minus 9. We're going to add 9. Okay, and so this we end up with 11 is equal to 1x, or 11 is equal to x. All right, so our value of x is 11, so we just take this 3x plus 2, so that's QPA, 3x plus 2, plug in the 11, so 3 times 11 plus 2 is 33 plus 2, which gives us an angle measure of 35 degrees. All right, so that's it for this lesson, and make sure that you've got those notes copied down, and make sure that you ask me any questions if you don't understand something. We'll talk to y'all later.